So we're starting the MCQ solution of the light MCQ today. Question number 1 is actually pretty simple. One of the things that I actually would like all of you to remember for the waves chapter is that whenever a mirror creates an image, the minimum required height for the image is exactly half of the person's height or the object's height. This can be shown by a very simple figure, which I should be able to find. Yes, got it. Oh, acha, yes. The eye problems. Yeah, I'm gonna address the eye problems just after a while. Thank you. Thanks for reminding me. It's not too big. Uh, so let's have a look at this scenario, and I'll tell you why this is important. To see the full image of a person, the mirror length should be at least half of the person's total length. Here is one of the examples that we have. Let's say this is a person, this is the top of the head, tip of the hair, and the eye is right over here. To be able to see the person's total image, light from the shoe and light from the hair should reflect off the mirror and which reach to the eye. So if we try to extend the line of the mirror, we can actually find out the possible image position for the head, which is going to be work along this line, and we can also find the position of the image of the feet, which is going to be about around this line. So this is the person, actual person. This is the image, which is represented as HC, which is a bit dotted line over here. So to have this both reflections reach to the person's eye, we need the mirror to be at least this much long, which is represented as IB length over here. Now, important for you to understand that light rays are going to come over here and come from the head and eventually reflect to the mirror and eventually reach to the eye. And the same is going to be happening over here. Obviously, this is going to be an isosceles triangle. Now, for the case of a human being, these two positions can be a little bit in front of each other. But if you consider for a standard figure, for example, let's say for a line object, which we had in right over here, it's not a very big image, but I believe it can be helpful to understand what I'm trying to say over here. So if we have a look over here for the light diagram, maybe a little bit smaller can help. Yep. So if you have a look at this figure, so here it shows that light from the head should reflect off the mirror, which reach to the eye. Light from the feet should reflect off the mirror and reach to the eye as well. So if the mirror is smaller than this length mn, then we wouldn't be able to see the entire image as well. So let's say if the mirror was, but if the mirror is somewhat bigger than the length that is represented as mn, we can still be able to see the whole person's image. And one thing is pretty interesting is that this big triangle that you can see right over here, this triangle is such a triangle where this is the midpoint of the CA arm and N is the midpoint of the CB arm, because these 2 points are equal far apart from each other. So the length of this light ray and then the length of this light, this arrow, this line, imaginary line behind the mirror, they should be exactly equal. Similarly, within this side, these two arm lengths are also equal. So these three sides are exactly equal. And if you consider by, if I label by different color, these three sides are also exactly equal. So within this triangle, this is the midpoint of arm AC, I to the image position, and within this arm, N is the midpoint over here, which by geometry proves that MN should be half of the length AB. And for our plane mirror, we know that the image height and the object's heights are exactly same, because image and object are of the same dimension. And this same thing can be extrapolated. I mean, this requirement that the image should be at least half the length of the object for the full viewing of the object is not dependent upon the object or the person's distance, because what I'm going to show you, let's say I'll copy this image. Let me copy this. I hope I can. If I try to expand this figure in a horizontal direction, let's say right over here. So let's say I'm gonna get rid of this. So let's say currently we have this situation. The person is this much far away from the wall. I can simply make this figure horizontally big. And even after that, I mean, whenever the person is standing far away from the mirror, this ratio of the midpoint is still going to work out just fine. You can see that the lines are becoming bigger or smaller, but the idea of, I mean, the person size and the mirror size can still be the same, even though the light rays have to travel a bit longer distance to reach the person's eye. The reason is, even still for this figure as well, let's choose a bit thicker line. Even for this line as well, this triangle going through the person, going all the way to this part, this triangle still pretty much manages the same property, that N is the midpoint of the EB1 line and C is the midpoint of EA1 line. So MN becomes half of A1B1. So that's one of the key parts that we have to remember. It's actually pretty useful for a lot of mathematical calculations, which I'm going to see in a bit after a while. So the reason I picked up this question is for the first MCQ that we have over here. It says that a person stands 2 meters in front of a plane mirror as shown. How far from the person is her image? Now, this is actually pretty simple. The person to image distance is 1 meter, 2 meters. So the image is going to be 2 meters behind the mirror. So the distance from the person to the image is going to be behind the mirror, not shown in the figure, is going to be 4 meters just by, because person and image are equal distance away. 4 is the correct response. In the same way, we can try for number 2. Number 2 is a bit interesting one. I'm going to pick that up. The diagram shows a patient having her eyes tested. A chart with letters on it is placed behind her, and she sees the chart reflected in a plane mirror. How far away from the patient does the chart seem to be? Now, for the sake of simplicity, in this case, apparently it is looking like as if the person is standing in between the plane mirror and the chart, but that's usually not the actual case for our doctor's chamber. The way it usually works is that if this is the mirror over here, the patient usually sits over here at a bit lower height, and the chart is usually placed somewhere around here, so that there is a bit of an angle, so the person actually does not block the view of the chart, which apparently is apparently looking like this over here. So the person is not blocking the view. The question that is asking us over here, how far away from the patient does the chart seem to be? Important information. Now, as we know from the properties of plane mirror, that in this case, the object, which is this whole table of letters, is going to be equidistant behind the mirror. So currently, the object is altogether 2 plus 3, 5 meters in front of the mirror. So the image of this whole thing is going to be 5 meters away on this side. So this is where the later chart is going to look like, where all the letters would be side shifted. Side shifted means they would be laterally inverted. That's the word we use. As a result, the person will be able to read them in a normal way. The letters in this case are printed laterally inverted, so that when they undergo another lateral inversion, they become easily readable, legible for the person. So this total distance from the mirror to the image is going to be 5 meters as well. So from the person eye, this is going to be a total of 7 meters. So D is the correct response for this question. Number 3 is just really simple, and to some extent, if you ask me, if it's a very simple question, it is an object O is placed in front of a plane mirror. A person looks into the mirror as shown on this diagram, in which position is the image O seen. It is always true for a plane mirror that the position of the image and the position of the object, if you join them together, you're going to get a straight line that crosses through the mirror at 90 degrees. So if you just try to see, if you join D and O, C and O, B and O, and A and O, there is only one line that will be perfectly vertical onto the mirror, which is going to be the line BO. So obviously the image of this thing is going to be working through this point, and eventually B is the image of this O point. That's pretty simple, actually. Number 4 says that, so I'm going to pick that up. There is a certain common mistake that the students sometimes do for this question. That's why I'm going to explain this a little bit. A boy stands beside a girl in front of a large plane mirror. They are both on the same side from the mirror, as shown. Where does the boy see the girl's image? Now, try to understand. Where does the boy see the girl's image? So basically, they're asking us, where is the image of the girl is created? No matter where the boy is, irrespective of the position of the boy, the image of the girl would be behind the mirror, equal distance away from her. This is always true. If the boy is observing from here, the image of the girl will be here. If the boy is standing over here, standing over here, standing over here, standing over here, anywhere, as long as the light rays coming of the girl's body gets reflected off any part of the mirror and introduces the boy, for example, like this, or maybe like this, or maybe like that, or even maybe like this, the light rays can be reflected off any path. But as long as the reflected light reaches the boy's eyes, the boy would be able to see the girl's image irrespective of the boy's position. Different reflection point can be used, but the image of the girl will be always produced behind the mirror, equal distance away. So irrespective of the observation, the image of the girl would be always A. The reason they use this point, that they are both at the same distance from the mirror as shown, the reason they use this information to confuse the students, that some students might think that this is pretty much where the light gets reflected off, so the boy should see the girl right over here. Highly unlikely. We don't perceive the person standing on the mirror. We perceive the person standing behind the mirror. That's how our visual works. So that's the correct response, not to mess up with the wrong information. And vice versa, we could also ask that why does the girl see the boy's image? That would be option choice D, if the question asks that, irrespective of the girl's position, that is. We have questions which are repeated. So moving on. Okay, let's have a question number 9. It says, a student holds this piece of paper with letters on it facing a plane mirror. The letters on the paper are shown. What does the student see in the mirror? So the idea is, the letters on the piece of paper, there is a plane mirror over here, which is vertical. So if I try to draw it in a bit of a 3-dimensional scenario, let's say this is a table. This is that letter, let's say T, O, F. There is a mirror, vertical mirror, standing in front of this piece of paper. The person is observing from here, person. Figure not drawn to scale. So how would this person see the image of these letters behind the mirror? So light is going to be reflected off over here, and eventually if we extend the line backwards, somewhere over here he should be seeing this part. But how would that image look like in these options? This is actually really simple. You can actually do this by the help of your calculator, or you can try to look to this printing from behind the page if it's possible. So just turn over the page, hold up this part of the printing across a light source, and try to see the opposite version of this thing. What you're going to find out that if we just invert it, we're going to get behind the mirror, we're gonna get the T look like this, O is gonna look like this, and F is gonna look like this. So the closer part should be closer, the further part should be further. O is just symmetrical, so O is gonna just look just like same. So I think C is the correct response. Can someone confirm if C is the correct response for this option?
How can we do it with a calculator?
Oh, you can use a calculator, provided your calculator has a big enough flat surface. Do you have a big enough flat surface for the natural display calculator? I believe you do. What you can do that in the exam, let's say this is the exam, the question that you are trying to help. So you can put up your calculator vertically over here. So if I try to draw it over here, just use the display part of a calculator as a mirror. So put up your calculator right over here, where these are the buttons of the calculator. So upside down, you're holding it like that, and try to see the image of the printed letters over here through the calculator screen. So you're basically gonna use the flat surface of the display part as a mirror. It can be tricky. You might have to move your head a little bit or move the position of the calculator a little bit, maybe the angle a little bit different. But with appropriate placement, you will be able to see the image upside down in the calculator screen, which can help you very easily to choose the correct answer. Try it now and see if you can do that.
I'm getting a B.
You're gonna get a B if you put the calculator right over here. For example, if I put the reflection surface over here, then we're gonna see the image where the T should be close to this thing, O should be over here, and F should look like that. What is the correct answer for this one, by the way? Did you put the calculator in this position or on the left?
Put it in front of the TOS.
If you put it on the left side, then you're gonna see this one. But if you put it on the top, that's what I understand from the question is says that a student holds a sheet of paper in letters on it facing a plane mirror. Yeah, I think facing a plane mirror. So this is actually not the setup. The setup is actually supposed to be, I think, as per the question, the setup should look like this. This is the printed paper, TOF. This is the plane mirror. The mirror is over here, and the student is trying to look from the side. So behind the mirror, it should look laterally inverted. Acha, I'm sorry. This is not supposed to be vertically inverted. This is supposed to be laterally inverted because the question is not about for this setup. I misunderstood the question. My bad. The question says that a student holds a sheet of paper with letters on it facing a plane mirror. So this is supposed to be the setup, where the entire image should be reflected off the plane mirror and it should be seen behind the mirror for this part. Well, if it's behind the mirror, it's simply gonna get a lateral inversion. So this whole thing should be inverted backwards, inverted horizontally. So that should be FOT, something like that. Yeah, B is the correct response, not C. I'm sorry. I misunderstood the question. I made a mistake, but did you understand what mistake I made?
Yes, sir. Yes.
So that's okay. Question number 11 can be a bit of a interesting part. So let's look at that. Says light is incident on a mirror and is reflected as shown. What is the angle of incidence and angle of reflection? Here's a thing. Be very careful to understand how much information is provided to you in the question. This is the incident ray falling off a mirror and the reflection is going off. The angle of deflection, this is the angle which is labeled as 80 degrees, what we call the angle of deflection. It basically means how much did the incoming ray bend. How much did the incoming ray bend? So it was incoming this way, then it was deflected in this direction. The total amount of deflection angle from the original direction is 80 degrees. So we have to use this information to find out the angle of incidence, angle of reflection. It's really not that hard. It's pretty simple. You can see this is a straight line. So if this is 80 degrees, by virtue, we'll know this total angle is supposed to be 100 degrees, which tells us that on one side of the normal, this is going to be 50 degrees, and on the other side, we're also going to have 50 degrees as well, because we know I equals to R. So that basically solves the problem in this case, which is going to be D is the correct response. Just try to use basic geometry ideas, and that pretty much solves the problem.
Sir, in the previous question, what would have been the question if what you did was correct?
The question might actually rule. I mean, if this was the correct setup, how does the wording needs to be? That's your question, right?
Yes, sir.
The question could read like this: a student holds a mirror on top of a paper, or above a paper, no, on top of a paper. A student holds a mirror on a piece of paper that is on a table and sees the image through the using the mirror. So there has to be clear indication that the mirror was placed vertically on the piece of paper. So it can be either like that, or it could also be, let's say the paper is over here, there's a mirror on the roof. The student is trying to look in the roof, how does the object looks like. So if the writing and the mirror are at perpendicular to each other, for example, the way I have drawn it over here, then you would get the answer number C. So if the question clearly stated something like that, which it didn't, and I misread it. Bucho.
Ji, sir, thank you.
No problem. Good question, by the way. That's what I was 22, and then question number 12 is actually very simple. It's one of the very common uses of a plane mirror, other than for looking our face. We can use plane mirror to make a very simple periscope. Periscopes are actually objects which can help to see objects where above our visual level. Very useful in warfare, because we can have spare periscopes, but we cannot have spare head. So the idea is very simple. The first thing that we need to understand, that whenever we see something, light from the object has to reach into our eyes, not the other way around. We are not sending light to see the object. Light from other sources should be reflected off the object that we want to see. So from a source, light falls onto the object. The object makes a bit of a reflection, dispersed reflection, or irregular reflection, and then the light should reach to our eye for us to be able to see that object. So all the questions over here which actually shows the light rays coming out of the eye are by default not acceptable. For example, here the light is going out, here the light is going out, not acceptable. That's the first thing. The second thing is very simple, is that because we have 45-degree angle of mirror, so the incident angle should be also 45 degree, reflection angle will also be 45 degree, which means all the reflection, both the reflections from the first mirror and the second mirror, they're going to be with a 90-degree deflection angle. So obviously the correct choice is C. We cannot have dissimilar angles over here. For you can see over here that for option choice A, the incident angle and the reflection angles are obviously not equal. If you try to draw a bit of a normal over here and try to see the observed angles, they're not going to be equal. Or even if you don't want to draw, because incident angle and reflection angles are also always equal, the angle these rays make with the surface, flat surface from which they are reflected, those are also supposed to be equal, which means if you just try to visualize these two angles, let me just copy this. If you try to visualize these two angles, let's say this one and also this one, if you compare these two, you should know that they are not equal. So that makes A not acceptable. So C is the only correct choice. Periscopes are actually pretty fun. Number 13 is something that you know how to deal with. I'm going to go for number 14. Question number 14, have a look at question number 14. It says 3 students stand 2 meters apart in front of a plane mirror, which is 3 meters long. Student Y is standing opposite the midpoint of the mirror. How many students can see the image of the other two? Try to understand. How many students can see the image of the other two? So to solve this question easily, what we can do is we can figure out the possible position of their images. Images are always created behind the mirror for a plane mirror and in a straight line that cuts the mirror line by 90 degrees. So student Y should be seeing him or herself right over here. I'm gonna label this, let's say Y prime as the image. Student X, although student X doesn't have any part of the mirror in front of him, so light cannot reflect off the mirror and reach to himself, but light can very well reflect off the student X from a certain amount of the and reach to student Y, in which case he should see this student should see the student X's image behind the mirror, and light can also get reflected off another point and reach to student Z as well. So I'm going to rub off these lines because we don't need that. If we want to find out the position of the student X, simply extend the mirror line and find out the possible position for the X prime. In the same way, we can find out the possible position for Z prime as well. So these are the image positions for this thing. The key idea is very simple. The mirror is only this much long, which means student X cannot see their own image, but they can see Y and Z. Student Y can see all three of them images. So because light can actually reflect off from here, right here, light can directly reflect bounce off to his direction, and light can also reflect from here to here. So student Y is the only student who is going to be seeing the image of all the 3 persons. Student X is Y and Z. Student Z sees X and Y. So all 3 of them sees the other 2. Additionally, Y also sees himself. So the question says that how many students can see the images of the other 2? That answer is 3. All 3 of them can see the images of the other 2. If the question, so this is the conclusion of the discussion for this part, but the question could be somewhat tricky. If the question said only, what would be your answer? How many students can only see the images of the other 2? What do you think?
1.
2.
The correct response is 2. Try to understand. I didn't ask how many students can see the image of themselves. That would be 1. Why can see themselves? How many students can see the image of only see the image of the other 2, which means they only see the image of the other 2. They don't see themselves. How many of those kind of students are there? How many students can only see the image of the other 2? So excluding themselves, that answer would be 2, because X sees Y and Z, Z sees X and Y sees all 3 of them, including him or herself, which means we cannot include if the question has an only in within. That would be, so if there was an only included, that answer should be 2. And then the third option, that how many students sees the image of themselves, or that would be only 1. Student Y sees their image only. X and Z do not see themselves. বুঝা গেছে?
জি স্যার।
আচ্ছা। If you go for the next one, it is simple. It is simple. আচ্ছা, 18 number question আসলে স্টুডেন্টরা কনফিউজ করার মেইন কারণ হচ্ছে যে because the way the figure is drawn. One thing that you need to understand, whenever light rays will be reflected off a plane mirror, the original type of light rays would always be within their part. Or in other words, I can say that if you have parallel rays reflected off the plane mirror, after reflection they will be parallel. If you have convergent rays, after reflection they will be convergent. If you have divergent rays, after reflection they will remain divergent. There is no going around this thing. So which basically means the reason it actually works is because a plane mirror simply reflects the ray at a perfect transformation idea. So you guys have learned transformation in your math. So if you just try to understand, let's say if this is your reference line, if let's go for option choice A. This light ray was going in this path. So this was the original path of the light ray. The mirror simply is going to reflect it on the other side, which means that reflection is going to look to be equal angle producing over here and here. These are not incident angles. I'm just trying to give you the idea of deflection. The mirror simply what is the word? Not transfer. It only reflects. The mirror only reflects the position of the line in which it was supposed to be in the opposite direction, on the opposite side, so that it can go forward. So that basically means that this is the correct response for this answer. Now you might wonder, the reason many students may find it difficult to choose this option as an answer, because here they see that the light rays are not falling into the eye. So how the person would see this? Here's the deal. The person doesn't have to exclusively get these two light rays. You have to understand that O object does not only produce two light rays exclusively, it produces a bunch of light rays around itself. These two light rays are simply used to show a possible pathway how the light rays actually reflect. How much light ray does the eye actually need? So if I try to elaborate the view of this, let's say this is the eye, where this is the choroid. Choroid is the black part of the eye, which basically gives the color of the iris. And at the center of the choroid, we have this hole, which we call the pupil, the tiny hole through which light enters into the eye. Multiple light rays seem to have to pass through this hole and eventually go through the lens, which is right over here, and eventually merge at a specific point on the eye, which is the retina. That's basically how the image is going to be created. We don't have to have all the light rays coming out of an object enter into our eyes. These two light rays are shown over here for the case of judging you. So in many cases, students speak O because they feel like light rays should fall into the eye, but that's not clear. That's not correct, because if the light rays were initially divergent, they will remain divergent after reflection. Or in other words, I can say that the light rays were supposed to go this way, and they are supposed to go this way. Because of the plane mirror, they're simply gonna get reflected from this side onto the other side. So C is the correct response for this one. Don't make such mistakes. I hope you don't. Then we have a lot of repeated questions. I'm gonna go for 21. Have a look at this question. I meant 2.2. A ray of light passes through a rectangular glass block. It is refracted and then totally internally reflected, which diagram shows a possible path of this ray. Now, whenever we have this kind of figures, there are multiple things we need to judge. First of all, the things we need to judge is number one, is the I and R logical? Now, I'm using the term logical because you have to consider depending upon where the light is going. If it is going from a denser into a rarer medium, or I can say if it's going from a faster into a slower medium, then incident angle should be bigger, refraction angle should be smaller. If it is going from a slower into a faster medium, then incident angle should be smaller and refraction angle should be bigger, or it should bend away from the normal. This is the first thing that you have to judge for multiple different side change scenarios. That's point number one. This is the most common thing that will lead to your answer for this kind of figures. The next point, which come handy in many cases, whether the critical angle is significantly big or not. Because sorry, not the critical angle. Sorry, if you consider for the total internal reflection, whether the incident angle where the total internal reflection is shown is significantly big, because we know by virtue that total internal reflection only happens when the incident angle is bigger than the critical angle. So you need to have the incident angle significantly large for the total internal reflection to occur. Judging by these two logic, you will be able to solve all kind of questions that have this. We might have rectangular glass block. We might have what is it? We might have semicircular glass block. We might have a prism. We might have a bit of a raindrop undergoing a bit of a reflection and whatnot. But these two logics will always help out to choose the correct answer for an MCQ question. So let's have a look at go for them. Question number A. So what do you see that option just A? What do you see that this light ray comes in onto this rectangular glass block, enters through this path. Is it all right? It might be. We let's say we're gonna try to draw a normal at the incident point. So if you just draw a normal over here, and I highly recommend that you physically draw this because you should get used to the measurement of angle. You don't have to actually measure. You can see that the incident angle is large and the refraction angle is small. So as the light ray falls from air into glass, it is actually following the actual case of total of refraction. Then it falls within this side where the incident angle is actually very, very small. Take a look at this one. This is the incident angle onto the bottom surface. So let's say this is surface number 2. This is surface number 1, surface number 2, and let's say this is surface number 3. I'm using these defining these three different surfaces just for the sake of convenience, depending upon three different light incident that the incoming ray is going to go through. First, it undergoes a bit of a refraction. Then we have reflection, which is supposed to be totally internally reflected. So total internal reflection, we're looking for that. And then on the third surface is undergoing another refraction. So that's why I'm saying three surfaces, because in many cases it can be individual three surfaces. For example, option just B, you have surface 1, surface 2, surface 3. So defining the surfaces in terms of the light incidence actually helps, just for the sake of discussion. So what you see over here, that even though the light ray is falling on the bottom surface, surface 2, at a pretty small angle, we are showing TIR, which is highly unlikely, because for the total internal reflection to occur, incident angle should be bigger than critical angle, which means incident angle should be somewhat significantly large, which is not shown over here at all, like not at all. This might be correct, provided we do not have any better answer to choose from the option choices, because we do not know what kind of glass are we talking about, or we do not also have that it just says over here, if you have a look, a ray of light passes through a rectangular glass block. It doesn't say that this surrounding medium is air. It could very well be something less dense than air. You might wonder, is it possible something to be less dense than air? I don't know. As far as I understand, that air or vacuum is the fastest medium for electromagnetic waves. But hypothetically, let's say, because the question doesn't specify, we do not know what is the surrounding medium. So maybe it is possible for us to have TIR with such small angle. Maybe. I'm not discarding this altogether, because this looks logically acceptable, but it's not very good of a choice because the incident angle for the TIR is too small. So we're going to judge the other options and see if we can get a better answer. Coming to B, have a look. Here, this vertical surface is our entry surface. So our surface 1. So let's say I'm going to draw a normal over here. Incident angle large, reflection angle small, well and good. Here, this is the second surface. This is the normal over here. Incident angle is really large and we're having TIR. Looks really acceptable. And then on the third surface, we are having, this is the normal, and the incident angle is small and the refraction angle is large. So it's all making sense. Between these two, if I have to judge one correct answer, I'm definitely going to go for B, because here the incident angle is shown to be significantly bigger. Do you understand why? Why am I choosing B? If I have to choose between A and B, I'm going to show you for C and D as well. They are basically wrong. If you go for option choice C, you will see that if you just draw a normal over here, you will find out that your incident angle is really small and refraction angle is large. So I is small, R is large for air into glass delivery, not acceptable. So you see one error, you can skip judging the remaining because this is not going to be acceptable, period. Same problem over here for option choice D. If you draw up a horizontal line, which is going to be work as our normal for the vertical surface, we're going to see incident angle small and refraction angle pretty large. So not acceptable either. And between A and B, I'm definitely going to go for B, because B actually shows us a pretty large angle, incident angle, where it is more likely to be bigger than the critical angle, but not for this one. Judgmental procedure gulo bujha geche kina? They may take some time, but as you slowly practice further, you slowly gonna require less time. And one thing that I'd like to put in, that whenever you're trying to draw perpendicular on a figure fast, the easiest way to draw fast perpendicular is by putting a protractor's 90-degree line with the surface. So let's say let me just show you what I mean. Let me just paste this figure one more time. This can actually save you some significant time whenever you are in a hurry, which is always the case for an MCQ question. Let's say you're trying to draw a normal over here. So what you need to do, put your protractor side right over here in such a way. Protractors always have their border over here, and their actual 0, 0 line is actually right a bit above the plastic body. So this is your 0, 0 line or 0, 180-degree line, but the 90 degree is always exactly at the middle. So align your 90-degree line with the surface and use the edge of the protractor to draw your vertical line. So you don't have to give a point and then join the 2 points. You can just go by drawing the perpendicular in a single step. This can save some time. বললাম বুঝছো কি আমি কি বলছি এখানে? I guess it makes sense. Does it?
Yes, sir.
Okay. এরপর দেখি এখানে আর কি কোশ্চেন আছে. Which pair of quantities is not proportional? We actually have this is actually a composite question which actually has a lot of different questions from multiple different chapters. So we haven't yet seen. Did you do electricity properly? Only electricity করা হয়েছে না? Hold on. তোমাদের সাথে কি আমার
Potential divider পর্যন্ত পেয়েছি।
পটেনশিয়াল ডিভাইডার, হ্যাঁ পটেনশিয়াল ডিভাইডার পর্যন্ত হচ্ছে ডিসি সার্কিটের লাস্ট পার্ট। এরপর যে পার্টটা সেটা হচ্ছে ইলেক্ট্রোম্যাগনেটিজমের পরে প্র্যাকটিক্যাল ইলেকট্রিসিটি চ্যাপ্টারে পড়তে, সেটা হচ্ছে লাইভ, নিউট্রাল এবং আর্থওয়্যারে যে এই আগুলো আছে ওটা আমি ইলেক্ট্রোম্যাগনেটিজমের পরে পড়ে। পটেনশিয়াল ডিভাইডার পর্যন্ত হচ্ছে ইলেকট্রিসিটির ডিসি সার্কিটের বেসিক ক্লাস। Okay, so you do know that current and potential difference of a resistor at a constant temperature, they are actually proportional. That's basically what Ohm's law is all about. I proportional to V. Here the correct choice is A, because angle of incidence and angle of reflection for a light entering a glass block, they are not proportional. Sine of angle of incidence and sine of angle of refraction, they are proportional. Try to understand. The refractive index is given by this ratio, n equals to sine I by sine R. Or if I just do a bit of a cross multiplication, I can write sine I equals to n, which is supposed to be a constant, multiplied by sine R. Or if I take away the n constant out, I can write sine I is directly proportional to sine R. That is a correct okay relationship. That sine of angle of incidence and sine of angle of refraction, they are proportional to each other, not those angles themselves. So that's that. এরপর এখানে একটা সিম্পল ক্যালকুলেশন আছে, এই ক্যালকুলেশনটা খুব ইজিলি করা যায় যদি ভুল না করো। সেটা হচ্ছে the question is asking us what is the value of the angle mark x, and they have also given us that for a certain parallel sided glass block the value of sin I by sin R is 1.50. Here they are meaning that the value 1.50 is the refractive index, but because this number is bigger than 1, let me just pick this question. Because this value is bigger than 1, so it necessarily means that this number is applicable whenever the light ray was going from a faster into a slower medium. This is obviously true. Here we are asked to calculate the value of the angle marked angle x, which is our incident angle inside the denser medium, and the refraction angle, which should be made with the normal, should be 30 degree. And if you look at this figure, you should understand from our earlier discussion that you need to replace this ratio by sine 30 divided by sine x equals to 1.50. Now you might wonder, why should that be? Shouldn't it be sine x by sine 30 equals to 1.50? That is a no. I'll tell you why. 1.50 is the refractive index ratio which is bigger than 1. Bigger than 1 means what? Try to understand. If you have a ratio of, let's say, sine p divided by sine q, you're going to get a bigger than 1 ratio of this case whenever, only if angle p is bigger than q. This is obviously true. So that is only possible if the angle p exists in the faster medium and angle q exists in the slower medium. ঠিক কিনা? Check this out. Whenever light rays travel from one transparent medium to another transparent medium, in the faster medium or in the rarer medium, the incident angle or the refraction angle, whatever you consider, it's always the bigger angle. and within the denser medium or the slower medium, it is always the smaller angle. So that's why whenever you are placing this formula, you have to write it like that, so that the smaller angle is on the denominator side, so that the ratio is supposed to mean bigger than 1.50. And you can pretty well see over here as well that this is the smaller angle, this is the larger angle. So that actually makes adds some sense to the process as well. And then you just solve this problem, this equation for the value of x. The sources of mistake that the students do are two. First of all, many students actually forget to subtract this. They directly go ahead and use 60 degree in their equation and totally mess up the formula. And the second source of error is that some students can directly go by this, that they can write sine x by sine 30 equals to 1.50. This is going to be wrong as well, because it's not supposed to happen. So just be careful for the figure, and finding out the appropriate format for the equation gonna be helpful. I'm gonna ask you to try number 4 on your own. Have a look at it. Judge the pathways, and the question is asking which path is not possible. So you need to find out a figure where at least one of the light incident is shown wrongly, either entry or the inside reflection or the exit. So the question is not possible. So দেখো তো এখানে কোনটা কারেক্ট আনসার হয়। তোমাদেরকে আমি প্রিজম পড়াইছিলাম কি? না তো। এবার ক্লাস শুরু করবো তো প্রিজম তো পড়াইনি না। আচ্ছা, প্রিজমের লেকচার দেওয়া বাকি আছে। আচ্ছা, প্রিজমটা আমি একটু পর পড়াবো, কারণ প্রিজমটা তোমাদের লাগবে, প্রিজমটা আছে তোমাদের সিলেবাস। I have a lot of repeating MCQs and whatnot. Which one do you think is the not possible path for the question? I mean, not possible. তোমাদের কি নরমাল একটা সমস্যা হচ্ছে? Tell me what it is, I'll help you.
Sir, perpendicular line top the সমস্যা।
I thought exactly so. আমি দেখাচ্ছি কেন কেন পারপেন্ডিকুলার লাইন আঁকতে হয়। I'll show you. Actual বোর্ডে হলে আরো ভালোভাবে দেখানো যেত হয়তো, but still I'll try my best in this virtual environment as well, no big deal. First, try to understand the surface orientation. Let's say for option choice A, this is where the light ray is entering into the glass block. This surface is vertical, right? So you want to draw a perpendicular on a vertical surface, which means your normal is supposed to look like this or this, which should pass through over here. এই জিনিসটাকে বুঝো। If you understand that you're supposed to draw a line like this, then it should become naturally clear that you are gonna try to hold your protractor in this alignment, where the flat edge of the protractor should be horizontal. তুমি চাইলে এটাকে এইভাবে হোল্ড করতে পারো, অথবা তুমি চাইলে এটাকে এইভাবে হোল্ড করতে পারো, doesn't matter, একভাবে হোল্ড করলেই হবে। What you're gonna try to do, align the border with the 90-degree line of the protractor. Bring it close and place the protractor onto the figure, so that the edge of the protractor, the flat edge of the protractor, is right on the point where you want to draw the normal, and align the 90-degree line with the surface, then you can use that edge easily to draw your 90 degree. বুঝছো কি বলছে? আগে জাজ
জি
করো
স্যার।
যে তোমার প্রোটেক্টরের অরিয়েন্টেশন কেমন হয়, প্রোটেক্টর কি আমি হরিজন্টালি রাখবো না ভার্টিক্যালি, মানে ফ্ল্যাট সাইড অফ দ্য প্রোটেক্টরটা কিরকম হবে। সেখানে যেহেতু সারফেসটা ভার্টিক্যাল, তাহলে আমার নর্মালটা হইতে হবে কিরকম, হরিজন্টাল। ভাইস ভার্সা আমি যদি এখানে যাই, সেম থিং, সারফেসটা ভার্টিক্যাল, তাহলে আমার প্রোটেক্টর অরিয়েন্টেশন হইতে হবে ভার্টিক্যাল। সো if I was doing this question, I'm gonna put my protector over here in this orientation, and over here I would prefer to put it in this orientation. If you wonder why, কারণ হচ্ছে এখানে লাইনটার লেন্থ বড়, সো আমি অ্যালাইনমেন্ট করার জন্য বেশি স্পেস পাবো, ভুল হওয়ার সম্ভাবনা কম থাকবে। এখানে লাইনটা ছোট, মেবি ইটস পসিবল যে আমাদের প্রোটেক্টরের মধ্যে যে একটা ছোট একটা সার্কেল থাকে, এই লাইনটা হয়তো ওটার ভিতরে পড়ে যাবে, সেক্ষেত্রে আমি অ্যালাইনমেন্ট করতেই পারবো না। বুঝছো কি বলছি? So try to preferably
Yes,
use
sir.
the bigger part of the line so that you can draw easier. For example, if you go up over here, this normal is gonna be look like in this. This is gonna look like this. So here the protector, I'm gonna put it this way. Here I might put the protector in this manner, and over here I might put the protector in this manner. So I'm always gonna prefer to use the longer part of the line, but it's not essential that you have to use the longer part of the line. You can use the shorter part as well, as long as it fulfills your requirement. Is perfectly all right. So এখন একে দেখো যে কোনটা ইলজিক্যাল বা কোথাও একটা ভুল আছে, মিনিমাম একটা ভুল আছে, because the question is asking us which of the path is not possible.
Sir, D.
Good. B is the correct response. B তে কোন সারফেসে ভুল হয়েছে বলতো?
The living part.
লিভিং পয়েন্ট, প্রিসাইজলি লিভিং পয়েন্টে যেটা হয়েছে, যেমন ইনসিডেন্ট অ্যাঙ্গেলটা হয়ে গেছে বড়, রিফ্লেকশন অ্যাঙ্গেলটা হয়ে গেছে ছোট, which is not supposed to happen because in this case the light is traveling from glass into air. So এখানে আমাদের ইনসিডেন্ট অ্যাঙ্গেলটা ছোট হওয়ার কথা আর রিফ্লেকশন অ্যাঙ্গেলটা বড় হওয়ার কথা, which is the mess up point. বাকি সবগুলো ফিগার ঠিক আছে। সবাই বুঝছো কিনা দেখো, see if you can come to this conclusion logically. আর তোমাদের এমসিকিউ পেপারে তো প্র্যাকটিক্যালি একটা বেশি কারেক্ট আনসার থাকে না। If you wonder is it possible, yeah, there are certain MCQ exams that goes around the world where there can be multiple correct answers or there can be zero correct answers. You actually score mark for doing answers like that. But that's not the complications that you have, so you will always have only one correct answer in your MCQ paper. So once you find out one answer, for example, if I'm judging by from A, I can see that A is perfectly okay. If I go for B, I find out that this surface, at this surface I have an error, then I would preferably not check for C and D. I'm gonna directly mark out B and then we should move on. But if you have enough time, you should definitely check C and D, because whatever you're judging over here might be somewhat wrong. You might come across a bigger mistake, and you might, if you compare, it can happen in some cases that your judgment might have been wrong. But what I'm trying to say is that if you're confident and you want to save some time, the moment you get up the correct answer, you can simply move on to the next one. So moving on to the next question. Zarin, Wasima, বুঝে গেছে?
জি স্যার।
আচ্ছা। Number 6, 7. Number 9 is also the same way. Try this one, number 12. Just use calculator and tell me the correct option. Actually, these people made the question pretty easy. কত আসছে? 1.41 should be the answer, I think. 1.51. C is also the correct response. আচ্ছা, আমি নাম্বার 14টা একটু ডিটেইলস আলাপ করি যাতে তোমরা জিনিসটা বুঝো। এই কোশ্চেনটা অনেকবার রিপিট হয়েছে, সো you might take I recommend that you pay close attention. Have a look. The question says a ray of light enters a glass block at an angle of incidence I and an a ray of light enters a glass block at an angle of incidence I, producing an angle of refraction R in the glass. Several different values of I and I are measured, and a graph is drawn of sin I versus sin R. Which graph is correct? Have a look. All the y-axis are sin I. All the x-axis are sin R. So this is a graph of sin I versus sin R. Light is entering from the faster medium into the slower medium, which always mean that within the faster medium, the I angle should always be bigger, R angle should always be smaller, in such a way that this ratio n equals to sin I divided by sin R should be a constant. If I just cross multiply this equation, I can write it in this manner: sin I equals to n, which is the refractive index, multiplied by sin R. And what you need to see over here, for all of these graphs, this whole thing is our y-axis variable, this whole thing is our x-axis variable, and they are simply made by the proportionality y equals to nx. This is our equation. So this is basically y equals to nx, and y equals to nx or y equals to any constant into x basically gives you a straight line that passes through the origin, which means B and C are not acceptable, because these are the graphs which are not passing through the origin. You are looking for graphs which should pass through the origin. Now comes the question that between A and D, which one should we pick? Which one is supposed to be the correct response? Here is what you need to judge. This ratio of sin I by sin R, which is basically the gradient of this straight line, should it be bigger than 1 or smaller than 1? For any pair values of I and R, I is always defined as the angle inside the faster medium, and R is defined as the refraction angle, which is always defined within the slower medium. So the sin I by sin R ratio which one is supposed to be bigger? Sine should be always bigger than the sine r, or the other way around? I think sine should be always bigger, which basically tells us that the value of this ratio should be always bigger than 1. And bigger than 1 lines are steeper than 45-degree lines. This is one of the things that you should have learned from your geometry classes or math classes, that if we have a coordinate system y and x, the line that passes equidistant from the both the axes, that actually makes an angle of 45 degree where the gradient equals to tan 45 equals to 1. This line actually practically goes equidistant from both the axes at equal point. So this is actually y equals to x point, x line. If you have y equals to more than 1x, all of those lines are going to be on the steeper side. If you have y equals to less than 1 into x, all those lines are going to be on the lower side. So if you now just have a look between the option choice A and D, you should see that this is an angle bigger than 45 degree. This is an angle smaller than 45 degree. So obviously your correct option should be A. So that you choose a line with a gradient. We don't know exactly how much is that because we are not supposed to measure it anyhow, but we can pretty well see that the gradient of this line is gonna be bigger than 1, where the gradient of this line is gonna be smaller than 1. We are trying to choose a line which has a gradient bigger than 1, and also the graph should pass to the origin. Both of these requirements are fulfilled in option choice A. So A happens to be our correct response. Number 16. It's a good question. I want all of you to try this. You have your paper, you can look over there, or I'm putting it in a Zoom fashion. You can also try it from here and try this. A little bit of help. Here, the refraction angle after the first surface is 40 degree. This should help you to find out the incident angle on the second surface, which is this angle. If you just extend this to 90 to two of these perpendiculars, you should understand that you're going to come up with a right angle triangle. So you should find out this angle pretty easily and compare that with the critical angle and decide whether you should have TIR or not. And from there, you have to take it further and check the third surface if it's necessary to see whether the angle of refraction is shown properly or not. Yes, the correct answer is going to be C. But did all of us understand how it is C?
Can you explain this one?
Sure. So what I was saying that here this angle is 40 degrees. So let me just zoom in a little bit more. This is actually equally applicable for all the figures. So this is a very common discussion. So because this is a 90-degree, right angle triangle, this is the right angle of the right angle triangle. So right over here. So which means the sum of these two angles should be also 90 degree. If this angle is 40 degree over here, how much do you think should this angle be? This should be 90 minus 40 equals to 50 degree. Tick it up.
Yes, sir.
Okay. Then the question also told us that the critical angle for glass is 42 degree, which means if the incident angle inside the glass while trying to lift towards air is more than 42 degree, we're going to have TIR. We can see that the incident angle inside the glass is going to be 50 degrees, which is bigger than 42 degrees. So we are going to have TIR. So A and B are not acceptable because A and B are showing that the arrow is, the light ray is leaving off the glass. So we should have TIR. So C and D are what we're going to check. They both make sense because apparently for both of these figures, the reflection angles are drawn to be equal. So all that we have left is to judge for this surface. Now all that you have to check is that whether the refraction shown on the third surface is shown correctly or not. Try to observe. This is your incident angle. This is your refraction angle. When the light rays is going from glass into air, the incident angle should be small and the refraction angle should be large. The angle inside the glass medium should be small. Angle inside the air medium should be large. So which of these two figures actually fulfill that?
C.
That's your correct response. বুঝে গেছে?
Yes, sir.
Beautiful. এরপর দেখি we have repeated questions quite a lot. Okay, then we have prism. আচ্ছা, prism পার্টটা তোমাদের একটু পড়ানো লাগবে। আচ্ছা, প্রিজম পড়াতে একটু সময় লাগবে। I cannot finish it in 2 minutes. শুনো, তোমাদের এর সাথে আমার নেক্সট ক্লাস কবে? মানডেতে না?
হ্যাঁ স্যার,
হ্যাঁ, মানডেতে 9:30। শুনো, মানডেতে আমি তোমাদেরকে আগে হিউম্যান আইয়ের বাকি পার্টটুকু পড়াবো, ছোট একটু পার্ট বাকি আছে, প্রিজমটা পড়াবো, তারপর আমি আবার এক্সিট এই পয়েন্ট থেকে আমি ফার্দার প্রবলেম সলভিং কন্টিনিউ করব। আমাকে ক্লাসের শুরুতে একটু মনে করায় দিও যে আমাদের কি বলে হিউম্যান আইয়ের একটু ছোট পার্ট বাকি আছে এবং প্রিজম এই দুটো জিনিস পড়ানো হয় নাই। I'm calling it a day for today. Yeah, thank you very much. Assalamu alaikum.
Assalamu alaikum, sir.